In this video, I want to illustrate how to use the gEAR compare tool. So initially, the gEAR was used primarily as a data viewer, but over time we started adding analysis tools into it, and the first of these was the comparison tool. There are two ways you can access the compare tool from the website umgear.org. It's here on the left. You can, in this box, just click Perform Comparisons. The other way, and it's probably more common, is you'll want to do it from the dataset you're interested in. So if you use the site in the normal way, I have the hearing profile selected. If I search for, say, RFX7, I see all the results for that gene. And if any of them are of particular interest, such as this one, we have one that's hair cells versus epithelial non-hair cells, and you want to look at the full set of genes across those two conditions. That's what the comparison tool is for. We can use it to quickly compare between two different conditions or cell types within a data set, but we do not support cross dataset comparison, which is statistically quite a bit more difficult. From any of these data sets in a profile, you can use the select box in the corner and choose compare. Here on the left, it will have pre-selected the data set you entered with, and also reads the conditions that are in that data set. So in this one, I'll leave the top, the cochlear epithelial hair cells, and I'll compare that against the vestibular hair cells. Plot. Some of the filters you can see here is by default we're doing a log2 transformation. You can turn that off or do log10. You'll notice the missing gash along the center. That's because those that are along the axis are not very differentially expressed, and they also contribute a lot of points to the graph, so it makes the app a lot more responsive if we filter those out. So by default, it's not showing any of those genes for which there's not at least a twofold change, but you can turn that filter off or do a higher one to 3. You can also filter based on standard deviation, but we're not doing that currently in this one. You'll notice there's also significance test values. This data set doesn't have replicates, so we can't do that, but it detects automatically. If I look in here, you can select a different data set. I will go to one that I know happens to have those. And notice now the significance test options have enabled. I'll compare the Dieter cells versus pillar. Let's also select significance. I'll just do a standard t-test between the replicates. And then you can choose the p-value cutoff, and you have two options. Initially, I'll plot now. Initially, you can tell it to colorize those which do pass the significance cutoff. In this case, they'll be colorized red. Can still be a little bit busy since there are so many data points. If you choose filter instead, then it will regenerate the plot, but this time it will simply remove those which don't pass the significance cutoffs. Then the plot itself is interactive. You can hover over any data point if you want to see, for example, what some of these outliers might be. This shows the gene symbols PRG2 and the p-value associated with it is 0.01. You can hover over any of them. There's controls up here for if you want to save. You can download the image as a PNG, or you can pan and zoom within the image. One of the useful things is if you see a cluster of genes and you're interested in keeping them, you can draw a box around them. Let's see, let me say box select. There's also a tool if you want to do like a lasso select, will allow you to do a very custom shape. But when I select those, you'll notice the right portion of the screen changes. It provides a tabular list of the genes that I selected. You can do a few things with that. You can download it as a text file, or you can save it as a gene cart. I'm going to click that. You can give it any name here. I'll give it YouTube demo. Save that gene cart. Now back on the home page, let's say if you were that gene cart will stay within the system. So if I had in the past, if I was using the interface, given any profile, if you have any gene carts saved, this will appear where it says gene carts. If you select it, here's the YouTube demo. It preloads the box with all the genes that are in your cart, turns exact match on, and if you click search, you'll get the results list for that set of genes. That one took a little while because there were so many within the set. But as you have them, now you can click through and sort of quickly see the difference between that gene expression in the datasets that you have loaded. So that's it for this video. That's how the basic comparison tool works. And in another video, we cover the much more advanced analysis tool, the single cell workbench, which is, of course, appropriate for those data sets which are single cell expression rather than bulk RNA-seq that is more appropriate for the comparison tool. Thanks for using the GEAR.